Hey guys, my name is Vivek Sharma. Today we can cover this interesting problem that's called the maximum area of Iceland. So in this kind of the problem we have been given this grid and we have been tell okay we are having it's containing only 0 and 1 and Iceland is a group of 1, all the 1, right? So 1 is representing the land and 0 is representing the water, right? So 1 representing the land, we have to count that all the how many what's the area of Iceland, right? And if, in fact it is the what is the maximum area, it's not only area, right? So this is also area, 1 is area, and I copied pasted this grid here just to make it clearly. So this one is also having one area, right? So this is area, this area is 1, right? And if I count these ones, so they are 1 2 3 4, so this area is 4, and then this 1 2 3 4 5, this area is 5, and similarly this 1 2 3 4 1 2 3 1 2 3 4 5 6, so this area is 6. Similarly we will just keep counting all the one, right? So they are 4, and we have to count the maximum. So this maximum till maximum is 6, but if I found any other maximum, then that will be the maximum area of Iceland, right? So that's how we need to do this. So if I traverse this all the row wise and column wise in the this 2D grid, right, row and column, if I use the to for loop and I just keep traversing this, then that's the one way that I can find. But only traversing row and column will not work here, because I need to find all the, basically I just need to go back and forth. When I say go back and forth, I need to go up down left and right as well. And that's how this depth first traversal or breadth first traversal comes into the picture, right? So in this particular problem, as we are seeing, whenever we are finding one, we just keep going deep basically, and then we can use the recursive depth first traversal approach. There might be different other approaches as well, but it looks like more intuitive here to solve this problem. And we just check, okay, if it is 1, then just keep counting. If it is not 1, we will just having some couple of base conditions. So base conditions like if it is not end of the matrix or starting, or our index is not negative, right? These will be the couple of base conditions. Another important point to remember during the recursion is, or depth for traversal is, whenever we are entering into the recursion, we have to mark it as a visited or non-visited, or another way is we have to take some auxiliary array that's called boolean array as a visited, so that we can keep a track of each and every cell whatever we have visited. And the reason to do that, because let's take this example, right? So let's try to undo a couple of things here. So let's quickly take this example here. Let's say this, right? So if I am marking this one, right? So and I went down and I went to this one, right? And this is blue color. So let's say I'm on the blue color one, and now I have to again check up down left right for all the 4 directions I need to go, right? And if I check the above one, this one, another one that I just marked in the blue color, that's already visited, right? And if I did not mark it as a visited, then I will reconsider it again, and that will be giving the misleading result. So that's why whenever I traverse through, I just need to make sure that I'm just marking it, okay, that I already visited. So during the recursion, I will check that, okay, if it is already visited, then I don't need to consider it again. And that's the reason we will be just using either, we can use either boolean array basically to keep a track of all these cells, or another way is basically more optimized way will be just keeping this grid itself, just keep updating the grid itself, so we don't have to take any additional space, but we will be reusing the same grid as well for our visiting or non-visiting thing. So let's quickly create couple of placeholders, and then probably we will come back again to the whiteboard to understand what we are trying to solve this problem. So let's take the maximum area. Initially it's 0, and as we discussed, we can just start our 2 for loops here, right? The 0 I is less than, let's say this is grid dot length I plus plus, and int j equals to 0, j is less than grid 0 dot length j plus plus. So one point to mention it here, it's grid 0, right? It's not grid. So whenever we are talking about row, so row are all these rows, right? So these are all the rows. Let's say row 1, row 2, row 3, right? So these are all the rows. When we are talking about the rows, we have to take the length of this row wise. So that's why grid dot length. So grid dot length will be till here, whatever the length is there. And uh, so grid dot length will be here, all these rows length, right? So these, all these rows, so grid dot length will be this, all the length, right? And when we are talking about the column dot length, so this will be the column dot length, right? So this will be the column dot length. So when I say the column dot length, basically, so it's saying grid 0 dot length, right? So grid 0 means basically it's checking the first row, sorry, the first column. um, First, this is a two-dimensional array, right? So two-dimensional array is basically whatever in the first row, and that's the length. So this is the our length. And the reason of doing that is basically because if it is a square matrix or something, then we can rely, okay, grid dot length will be the same as column length because it's 3 by 3 or 2 by 2. But it's not mandatory that row length and column length, they are necessary same. So that's why we have to check, like, whatever our first row is there, that length will, we will consider as a total column length, and that will be consistent throughout here because it's all the metrics, right? At least it's some metrics is there, right? So if I see if it is a square or not, 1 2 3 4 5 6. So yeah, if we count the row here, these are 8 rows and these columns are more, right? So this is just an example that this, it's not mandatory that it will be square. So that's why we are just taking the column is a grid 0 dot length. Grid 0 is first row, that length will be considered as the all the columns, basically how many columns are there, and we will be traversing it through here. So now we have to consider it basically 1, right? So whatever the land is there, that will be basically we have to consider. So let's say if we are doing DFS, let's create another helper method that's called the DFS, and let's say DFS is giving our area, right? So let's say max area equals to math dot max, right? Max area comma DFS, whatever the DFS will give us to us, right? And in DFS, let's pass grid I comma j. Okay, so this will be our caller method that will be keep calling this DFS method, depth first traversal method, and this will keep giving us the area of current row or column, whatever we will be passing, and then we will be calculating all the max, right? And we are putting this check as 1 because we don't care about 0, so unnecessarily we don't want to pass that 0 itself, right? So let's try to create this DFS method. I'm just doing the build. This will be int basically because our caller method is calling, expecting is some int value, the maximum area. So let's do this int grid, int row, int column. Okay, so now in the starting of recursion we have to mention couple of edge base cases. So this will be the base condition. So base condition will be, base condition will be like if it is row is less than 0, right, or row is greater than grid dot length minus 1, or column is less than 0, or column is greater than grid 0 dot length minus 1, right? So these are the couple of base cases. Then in that case we will be returning 0, right? And otherwise what we can do, we can just return, we have to calculate all these all the 4 directions. So that's what we can do, right? So let's do this grid. So this row minus 1 will go just above up condition. So if I go, for example, I am on this row, right, and if I am going to the row minus 1, then I have to go upside. So this is above direction, and then column, and then similarly I need to copy paste all these things basically. Right, so let's do this. So row minus 1 is above condition, row plus 1 is basically down condition, and then column minus 1 is left condition, and column plus 1 is the right condition, right? So that's how we will calculate. And we have to mark the wasted as well. So whenever we just entered after base condition, when base condition is satisfied, then basically row that column, let's say I am just marking it as again as 0, or for the basically simplicity I can mark it as -1 as well. So -1 is basically, let's say we already wasted, right? And if I already visited, I can check this condition as well here, so that I just make sure that I already visited, and I don't consider it again, right? So let's say if grid row column, if it is equals to -1, means it's already visited, then I'm returning 0, right? So if I do that, then I think that's the idea, that's how we want to do that. And let's try to see the compilation errors if there is any. So 11 is missing. Okay, so we need to return here the maximum area. Let's see it. So this output is 20 and expected is 4. So we have been given some metrics that's giving the incorrect result, right? So let's quickly see that what we are trying to do. We are going all the 4 directions, and then we are handling these base conditions, and then 0 itself. So if it encounters a 0, we just need to make sure that if it is this base condition is basically not correct. So if it is not equals to 1, then basically that will be the base condition. I will just be explaining that in a bit. So earlier what I was doing, I was just let me do the control Z, and I was doing -1. That's the incorrect base condition. So this is, I'm just considering only listed one. But what I need to do, I need to consider its visited one, as well as I need to consider that 0 as well, right? So whoever is not 0, whoever is the 0, so if I encountered 0, then I need to return from the base condition. I don't need to calculate this maximum area. And then another case is -1. So this basically, this case will avoid will escape 0 and -1 both, right? So if I am doing my not equals to my 1, then it will skip 0 and -1. But if I do equals to -1 only, then I will be considering only the visited one, but I have to consider here the 0 and 1, right? 0 and visited one. So I need to skip 0, all the 0, because that's the water, it's not the Iceland, it's not the land. And another is, another case is if it is 1 but it's already visited, and that's -1. So if I put not equals to 1, that will satisfy my condition, because not equals to 1 means either they can be 0 or -1, right? So that's how I have to be careful that what the base condition I am using. So let's try to quickly see that what's going on. So this is working as expected, as we discussed. So I think we should be good solution wise. Let's quickly analyze the time complexity and space complexity here. Let's say time complexity would be m into n. So why m into n? M is the number of rows, n is the number of columns, right? And we are just traversing m into n, and then basically we are just going depth first traversal also we are doing. So first time complexity, it will be m into n. And space complexity would be basically in the recursion. In the worst case, we have to go to, we might go to the all the, we might visit all the cells of the matrix, so it will be m into n, right? So where m is number of rows and n is number of columns, right? So that's how we can analyze space and time complexity. So the key takeaway from this problem is one is depth first traversal. Another takeaway is whenever we are just entering to the depth first traversal and we are just doing the recursion, just don't forget to make it mark it visited. So this is basically we are marking it as a visited, right? Marking it as visited every cell, and we just need to make sure that we are just not reconsidering the visited one as well as the 0 one, because 0 1 is the water, right? So that's why we just need to handle our base condition properly, so that it will not give the misleading result. And why we are doing 1 plus here? Because 1 plus basically we are just keep adding this recursively all the 4 directions, up left, all the 4 directions means up down left right. So row -1 is up, so this condition is basically up condition. row plus 1 is down condition, and row minus 1 is left condition, left direction, and then this is right direction. So these are all the directions, right? Direction. So they all are directions, up, down, left, and right, and that's how we can do. Hopefully this was useful. Thanks a lot. Have a good one. Bye.